So, Professor Bernards, you're a plenary speaker at this conference here in Belgrade. Did you have time to attend some of the sessions before your own sessions, and how does it look to you so far?
So I saw some presentations yesterday afternoon by younger investigators, and what struck me is two things. One is the enthusiasm of the investigators and also of the participants of this meeting, the active question and answer sessions. And the other thing that surprised me was the depth of the knowledge of the people in terms of how well they were aware of the field that they studied. I thought it was really an eye-opener for me to see that there was such deep knowledge of cancer biology here in Serbia.
And you talked about optimism here, right?
Yes.
And enthusiasm. Is that something that you actually see a lot when you give presentations across the world in conferences, or is this something specific for the Congress here?
You don't see that all the time, unfortunately. I would have hoped that when young people go in cancer research, they do so for a drive, a desire to solve the problem that we call cancer. At least that's why I chose it 40 years ago, right? And I see that less now, and I find it really refreshing to see that desire to know and enthusiasm to solve the problem with the people here. I think that's really refreshing, and I think we should see it more often, globally than I do, because I don't see it all the time.
So your upcoming session is called Meet the Experts, and you will meet some of the researchers and the participants of this conference. So what will be your key takeaway messages for the participants, and if you can sort of share with us any special message that you have for cancer researchers in Serbia?
I think I have two messages for cancer researchers. This theme of this conference is collaborate and innovate. Collaboration is a must, right? Because the problem of cancer is so big and the technologies are so complex that you can never master all of these technologies yourself. So you need to partner with people that can help you solve your question. So you need to be an extrovert person. You need to be engaging, interacting, to convince people to work with you. And that is a trait that is a must-have these days to be successful in cancer research. You must be outgoing and interactive. So be that. Otherwise you won't get very far just by yourself. And so that is a very important problem. And the other thing I would like to say is what I also said in my lecture yesterday. If you do what you did, you get what you got. You need to dare to be different. Do different things from what everybody else does. This is how you stand out from the crowd. This is how you make a difference. I know it's hard, but you need to think very deep about how you could be different from the rest of the crowd and stand out and do something that is truly original. Because change comes from disruptive innovations in our field. And disruptive innovations is simply doing something radically different. And that is hard, because you really need to understand what the problem is, what everybody is doing, right? And the example that I gave yesterday, where I said, everybody is trying to inhibit oncogenic signals to solve cancer. What if we did the opposite? What if we stimulate them to grow faster? They would probably die as well, and they do, right? So that is one of those examples where you say, dare to be different and see what you get, right?
Think outside of the box.
Think outside of the box. That's how you make progress, and this is how you make a career for yourself, right? It's hard because not every stupid idea is a good idea, right? Not every unconventional idea will get you somewhere. So that is the big challenge in this field. How do you be different and at the same time make progress in the field? That is where I think the trick is. It's not easy, I tell you, it's not easy, but it's worth doing.
Yeah, and I suppose that practice makes perfect in the end, so they have to try and test their ideas.
Well, you know, the problem is, you know, there is this joke about the train driver that crosses railway crossings and says, there is never a possibility for a car to cross the railway track because the things are always down, right? But that's what you call a bias observation, right? Yeah. When the train driver crosses the railway crossing, the cars cannot cross, right? So he thinks they can never cross. So by analogy, I talk about successful experiments from my lab because I don't come to a conference to talk about a failure. So people think that everything I do in my lab is a success, which is of course not true, right? So we have 10 ideas and one works out, and the one that works out I talk about. But for every success, I have 9 failures, right? So you need to accept failure. And that also means that if you have an experiment, you have an original idea, you should never fall in love with your hypothesis, right? I have some crazy idea and now I want to pursue it no matter what happens. If the first 3 experiments tell me you're wrong, you're wrong, you're wrong, then you should stop and think of something else, right? So giving up on an idea is sometimes hard to do because you can fall in love with your own idea and you should never do that. That's a big mistake. Have you
fallen in love with your ideas during your career?
Yes, I have.
Okay.
Yeah, and I have paid the price, right? Because you need to, at some point you come to the realization that your love was not reciprocal. that the idea was
you
simply
should find
wrong.
a new love.
You should find a new love, find a new idea, and then you can get excited again. And like in real life, you get excited again by a new person you meet. A new idea will hopefully then take you over your depression. It's
a very interesting observation about science because we always expect scientists and researchers to be like really serious, not making jokes, but this is a really nice conversation full of anecdotes. So
yeah, so I think scientists are just like humans, right? In that sense, there's nothing different about being a scientist. It is just that I think the difference between a scientist and a person having a regular job is that I have never worked a day in my life.
Because you love your job.
Because I love my job, right? I don't go to work to earn an income. I have found an idiot that is willing to pay me to do my hobby, the director of my cancer institute.
You should tell that also to the participants.
Right? But I've never worked a day in my life because what I do is what I love to do. Right? And I'm now 70 years old. I'm 3 years post-retirement. I go to the lab every day.
You still
Why?
work?
Because this is the thing I want to do.
Yeah. That's really amazing.
Yeah.
And you work in the lab, but you also run a European Association for Cancer Research. How does that work? Because you have so many members, it's 12,000 members, I suppose, across all the European countries. So what does your job entail and how do you like it?
Well, it's not as tough a job as it looks in terms of time commitment. We have a very good staff at EACR main headquarters in Nottingham in the UK. We have a CEO that is a full-time position, and those are the people that run the organization. The president is a figurehead but there is a number of things that you do. But I'm also assisted by a board of directors, like 15 people that are leading scientists in Europe. That Chiara Ambrogio is here as well, is a member of that board as well, and together we take the decisions on which conferences we organize, how we serve our members, because that's our duty. What would our members enjoy most? In times of COVID, it was about virtual conferences. Now we go back to, thank God, to
now no one likes Zoom anymore.
In-person conferences, right? Our annual meeting becomes ever more successful. We had 2,000 people and more in Turin, and we look forward to Rotterdam in June of 24. So we do a lot of things. We award fellowships, travel grants, small prizes to encourage people. We have recently installed what we call a early career investigator council with young scientists that advise us, because we're all older. When you make it to the board and to the presidency, you're not young anymore, and we really want to serve the young. So we need to have our antennas in the young crowd, and we have this young advisory board that will tell us what they think we should be doing to serve the younger investigators that are typically our members, our early career scientists. So
and what do they say? What would they like you to do? These younger generations of cancer researchers?
For instance, in the annual meeting of 24, they have their own session that they invite speakers who would they like to hear, so they can run the show there, and we'll see how that goes. That's the first time, and we'll see what the program is. We have given them complete freedom to organize it. They have organized a virtual meeting on using creativity in research. It touches a little bit on what I just said about dare to be different. Grants have the tendency to have aims and milestones where you are promising, I will do this and I'll do that, and that will be the outcome of it. How can you promise an outcome if you haven't done the experiment yet, right? So the grant system forces us into a rigid line of experimentation, and whereas the real breakthroughs come from these creative experiments that are never part of a work package or a specific aim, right? So how do you bring that creativity back into your research? That's what they had a brainstorm session on in a virtual conference, and there were like really original ideas from younger people that I think people can learn from.
So you talk about creativity. Was it like that? Were you creative when you started your career? It was 40 years ago, if I'm right.
Yeah, it was in 1980.
Okay.
So it's even worse.
Were you creative back then, and were you taught by your professors to be creative, or is that something that you learned during the years in the field to be more creative?
I learned it from Richard Flavel very clearly. There was one single person. My last master internship at the University of Amsterdam was under the guidance of a British scientist who was completely creative, out of the ordinary. And he said, no problem is big enough, or you can solve it if you really set your mind to it, right? He said, the brain can solve any problem, and if you can't solve it, you just don't want it badly enough, right? And that was his motto. And he said, you just go for it, and if you want it. And that stuck with me my entire career. When I came to do my PhD in a lab that was completely unimaginative, I brought into that lab a completely different attitude. They said, for instance, at the time, can you imagine, in 1980, it was not allowed to do recombinant DNA research in the Netherlands. And I was working on adenovirus transforming genes. And I said, the first thing we need to do is clone these genes, otherwise we cannot make mutants and study their function. And the simple answer was, it's not allowed to clone genes in the Netherlands. So I said, okay, so then I'll go to the United Kingdom, because there it is allowed, right? And they said, but then you need to apply for a fellowship, and that will take 6 months. I said, I don't have 6 months to spend. I'm going to go to the UK next week, and I'm going to clone these genes. And how we pay for that, we'll worry about later. And it was that kind of attitude that lab wasn't used to. But sure enough, 3 months later, I had cloned all the transforming genes, and we were beginning to make mutants in these genes and study their function, and we learned a lot from that. So it is, again, dare to think out of the box. If I cannot do it here, I'll do it there, right? You think you want to do it, and now you think, how am I going to make that happen, right? And that is often how things get done in science.
And now your mission is to pass on that creativity to your students and other younger colleagues, I suppose.
The problem is that you cannot pass that on. You find people that have that, and you find people that don't have it, right? It's not an acquired property. People are either conservative and risk adverse, or people are adventurous and dare to be creative. It's my experience that people come in two flavors. They have a career plan. I say, I want to get a PhD in 4 years. Please give me a project that is simple, straightforward, that I can solve the problems in 4 years, and then I can take the next step in my career. And you have people rare, much rarer, that sometimes you come into that say, give me something that is a real challenge, right? Because I really want to solve this problem. And those are the people that are going to make the difference in the field. They are rare. 1 in 50 maybe that I get into my lab have that mentality. But those are the people that are going to make the difference. Dare to be different. That's my message.
Thank you so much for your time and for the interview.
Thank you.